product of complex numbers in polar form. Remember, this is a polar form, okay? R times cosine theta plus I sine theta. And so if we multiply these two together, we get this one. And so what's happening is we're multiplying the r's, but what's happening with my thetas? We're adding them, right? So we add them when we're multiplying, we have the product. When we're doing the quotient down here, we are subtracting them. We're dividing the complex numbers in polar form, and we end up subtracting the angles. Okay? All right, so those are the only rules we have this lesson. Sorry, this lesson. Okay? So I'm going to pause this. We'll write down a couple examples, and we'll be done in about 3 minutes. So in this problem, they want us to find the product in polar form, and we just discussed that these are not in polar form, they're in rectangular form, a plus bi. And so if we look at this as ab, this ordered pair would be 2, -2, and this ordered pair would be -3, 3. What quadrant is this one in? 4. X is positive, y is negative. That's quadrant 4. What quadrant is this one in? 2. Because cosine's negative and sine's positive, so that's quadrant 2. All right, so we have to be aware of that to find our angles. So the first thing we want to do is write these numbers in polar form. So let's take the first one here, and let's find r. Remember, how do we find r? Square root of a squared plus b squared. And so that gives me 4 plus 4 is 8, which is 2 square root 2, right? Okay. Then we need to find our angle. Remember, our easiest way to find the angle, just a second. The easiest way to find our angle is to take y over x, which is b over a. And so theta then is going to equal the inverse tan of -1. And tangent of an angle equals 1, then the angle is a 45, right? Yeah? Okay. I did this in degrees because most of us add degrees better than we do radian measures. Okay? And so in quadrant 4, what is our 45-degree angle? 315. So I'm going to call this angle 1 we were finding. And this is R1. Okay? Now let's go back up and we'll look at what's R2. R2D2, I know we're all thinking it. So what is R2? Square root of -3 squared plus 3 squared. And so that's 918, so that's 3 square root of 2. Right? We said it's in quadrant 2. And so tan theta 2 is going to equal 3 over -3, which is -1 again. So the inverse tan of -1 in quadrant 2 is 135. again, it's a 45-degree angle, but we're in quadrant 2, so that's 135 degrees. Okay? So now we can apply our rule. It's going to be R1, R2 times cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. Okay? And so we had 2 square root of 2 times 3 square root of 2 times cosine of 315 plus 135 plus I sine of 315 plus 135. And so if we clean this up, I'll give you a moment to think about it. Now the Jeopardy song is over. What's 2 square root 2 times 3 square root 2 simplified to? 12.
And doesn't that
Because this is 2, right? And this is 6. 2 times 6 is 12.
and since the 135 or 315 plus 135 is 450, that equals a 90-degree angle. So would that be just 0 and the other one would be 1? So it all simplified to 1 I.
No, they want it in polar form. Okay? Plus I sine 450. If you simplify like you were saying, then we go back to rectangular form. That's not what we... Oh, wait a minute. That is how they did it. Sorry. You're exactly right. We're saying that if you couldn't hear him at home, Matt's saying 450 is 90 degrees. Cosine of 90 is 0. And sine 90 is 1. And so we just get I inside, and times 12 is 12I. Yeah. I'm surprised. I really thought we were leaving them in polar form. I did have a couple other examples here, but other than one of them I left in radians. I think this is as difficult as they come. So, oops, there. Our assignment is 11 through 27 odds. That's all you need to do. Hopefully you didn't shut this off at home. There's one example that number 20 is a little different. I have written -1 to the 1/4. Which is -1 plus 0I to the 1/4. Can someone read the directions to number 20? Make sure.
Says finding product of solutions, press to resolve in rectangular form.
Okay. So R is going to be the square root of -1 squared plus 0 squared, which is square root 1 or 1. Okay. Theta is the inverse tan of 0 over 1. And when is tangent equal to 0?
When the numerator is 0, so
This is actually over -1.
tangent is 0.
Sine is zero,
Yeah,
right?
0 or 180.
Yeah, but it's negative, it's 180 because
Yeah.
the x is negative 1, so that happens at 180. And so in radians, that's pi. Okay? So if we set this up, we get, I'm going to write it down even though it's unimportant. Cosine pi plus I sine pi to the 1/4. Okay, and again, so that we don't make the mistake of ignoring it when it's not a 1, I'm going to carry the 1 and I'm going to show this next step also. It's 1 to the 1/4, and we all know that's 1, but like I said, r isn't always 1, so we have to carry that through. And now, the way we treat this is we multiply our angle by that power. So what's pi times 1/4? Pi over 4. So this becomes cosine of pi over 4 plus I sine of pi over 4. And so what we're doing, with that exponent is we're multiplying it by the angle. Okay? That's how we treat that. We multiply it by the angle. And so we've already said this 3 times probably. That's all equal to 1, so we can ignore that. What's the cosine of pi over 4? It's a 45-degree angle, so what's cosine of that? What is it? Square root 2 over 2.
I just realized something. When you were talking about leaving it in a rectangular form earlier,
Yeah.
I did leave it in a rectangular form, just bi was 0.
Yeah. But I was saying I thought they were leaving it in polar form.
Oh.
Okay? We were just using polar form to get the simplified rectangular form answer. And I thought we were leaving it in polar form. Okay? What is sine of pi over 4? Square root 2 over 2. And so this one they're going to leave this way. I don't know why I have an approximate value here, but I did. These are exact. I don't know if they asked for that. Probably because some of them are we're going to have to round them. Okay? Some of them are not going to be nice numbers like pi over 4. Maybe we get 19 pi over 20. We don't know what that is, so we just round it up. Yeah.
Quick question.
Yeah.
Why exactly are you showing us number 20 from 98?
Oh, did I?
Yeah.
Oh!
Yeah, I don't.
97 is completely different.
Because my
You probably got your notes mixed up.
my notes and homework run together, but I don't have notes to
98.
9/8. That now it makes sense.
Okay.
Okay, I'll write that on there. Sorry if you're at home. This is actually an example from 9/8. And that's what I said. I'm surprised there wasn't a rule written on this. Well, there will be tomorrow. Or, yeah, tomorrow, I think. Okay? Sorry.